Tim Latimer, welcome to the Texas Power Podcast. Thanks for being with us today.
Great to be here. Thanks for having me.
I've been wanting to have this conversation for a while because I am so fascinated by geothermal, have been for a long time, back to my earliest days working on energy policy at the Texas legislature almost 15 years ago. But it does seem like we're at a moment that the geothermal is having a moment right now, and you're right at the center of that. So really thrilled to be talking with you, and thanks for taking time. So we'll start with a little bit of your background and to tell us a little bit about Fervo Energy, the company that you lead. But if you don't mind, can we just kind of start for those that really just don't know anything about geothermal? And for those that do, bear with us. We won't spend a long time on this, but I think it's important just to kind of start with the very beginning. We do have folks that listen to the podcast that are interested in the grid and ERCOT after the grid problems of 2 years ago that maybe really don't know what geothermal is. Can you kind of just start with an explanation from the highest level?
Yeah, absolutely. So at the highest level, the thing to understand about geothermal is that the Earth is really big and the Earth is very hot. Actually, the core of the Earth could be as much as 6,000 degrees Celsius, and it's not quite that hot on the surface. But the deeper you go, the closer it gets to that temperature. And so, really, throughout history, people have figured out ways to make use of that heat. And one of the ways that it comes to the surface is through hot springs. You can go back back into ancient times and figure out people utilizing hot springs at the surface for different activities. And but really what we consider geothermal electricity generation had its advent about 100 years ago in Italy, where there were big expressions of heat coming out of the surface through steam vents that people realized that if you put the right equipment at the surface and captured that steam, you could create electricity from it. So the first geothermal producing power plant started about 100 years ago. And the whole field of geothermal, it's all about using that heat for useful purposes. In modern geothermal, what that typically means is that we drill wells down to access that heat. And then we circulate water through that hot water area. And if it's high enough temperature, we create electricity from it. For lower temperature things, you can also do things like district heating or use that heat for agricultural purposes or other industrial applications. But really, geothermal at the highest level is just using that heat of the Earth in useful ways to create electricity or get some other useful energy. And the key thing about it today that makes it of so much interest is the energy that's created from geothermal has two attributes that are very important. One is that it's both carbon free. So it's a clean energy resource. It's a renewable energy resource. It lasts for a long time. And the second is that it works 24/7. So as we think more about the grid mix and reliability and pushing for deep decarbonization and how we actually make that work, the fact that geothermal is a 24/7 resource is one of the things that's making it quite important as well. But that's what geothermal is in a nutshell at the highest level.
Appreciate that. Yeah, and we'll talk about 24/7. I think the partnership y'all have with Google is really fascinating, and we'll dive into that some in this podcast. I also just want folks to understand, because a lot of times when you hear of geothermal, you might be hearing of ground source heat pumps, so cooling homes with geothermal. Your company doesn't do that, but it's not in the same class. It's sort of in the same broad bucket of geothermal, but there you're just going a few feet down and tapping into the temperature of the Earth only a few feet down, correct?
Yeah, that's correct. And it's somewhat different principles. And really, if you want to talk about categorizing geothermal, the shallowest geothermal is that ground source heat pumps. And what you're really doing is you're using a heat pump to heat or cool a space. And you're using the fact that if you go down a few tens of feet into the Earth, you actually don't have the major temperature fluctuations we have in the surface. So most places, once you get down deep enough in that tens of feet down, the temperature is around 60 degrees Fahrenheit year round. So it makes it really efficient to heat in the wintertime and then really efficient to cool in the summertime. So that's your smallest, residential or commercial scale, really shallow ground source heat pump. Sort of the next jump up is what we call direct use, which is where you're drilling deeper, usually a few hundred or a few thousand feet deep, to access resources that are hot enough to do things like provide district heating grids. And the distinction between ground source heat pumps and district heating is ground source heat pumps, you're just using that constant temperature for heat exchange to make more efficient heat pumps, whereas in direct use, you're actually using the fact that rock is hot. So it might be, might be 100 degrees Fahrenheit or 200 degrees Fahrenheit. And you can use that to create a district heating system, for example. And then you have what my company does, Fervo Energy, which is drilled deeper to that into higher temperature resources. Geothermal electricity generation can be anything from 300 degrees Fahrenheit to 700 degrees Fahrenheit, but it's high enough temperature that you actually get really high energy content, steam out of that, and you can create electricity from the geothermal resource itself. So those are sort of your three buckets of deeper geothermal, going from shallower to deeper. You've got your residential scale ground source heat pumps, then you have your direct use category, and then you have your geothermal electricity generation category. And of course, you can kind of mix and blend all of those in complicated ways, but those are generally the three ways to think about geothermal.
No, that's super helpful, and I often get tripped up and confused. So that's a very useful classification.
I will say our most common request on our website is if we can come to somebody's backyard and drill them a geothermal system for their home, and I always refer people to
public service announcement. Yeah, do not ask Fervo Energy to drill in your backyard.
I'll put in a plug for a cool company that I know. Dandelion Energy was a Google X spin out. They're one of the technology leaders in the geothermal heat pump space. So I typically refer people to that. Our wells, we drill 10,000 feet deep, not the kind of thing we're going to do in your backyard. We build, power plants that are on the size of powering, small cities. So very different technologies. I'm a big fan of ground source heat pumps, but just quite a bit different from geothermal power generation in terms of the scale and where we sit on the spectrum.
Excellent. And all in that category of there's a lot of energy in the earth, and it is a resource that we can tap. It is a renewable resource. So let's do, obviously, pardon the pun, drill down deeper into EGS, and because it is very interesting as a drilling technology. A lot of overlap between the expertise in the oil and gas industry in Texas and other places for this kind of resource. So let's talk a little bit about, first of all, your background, and then secondly, the company and sort of the roots of the company and where you guys are at right now. So you came to this space from oil and gas, correct? You worked in the oil and gas industry for a number of years. Tell us a little bit about that and how that sort of led you, or what the connection was to get into geothermal.
So I'm from Texas. I grew up in Texas, and then I went to the University of Tulsa and studied mechanical engineering there. And so I graduated in 2012, and it was right at the height of the shale revolution when it had become clear that technologies like horizontal drilling and hydraulic fracturing were totally upending what could be done from a domestic energy production standpoint in the U.S. And I joined up with BHP Billiton, based out of Houston. There as a drilling engineer. And I was working typical early career drilling engineer role out in the field, being an on-site engineer for our drilling operations in South Texas. And I was working in the Eagle Ford. And the Eagle Ford, in terms of an oil and gas resource, actually has temperatures that are slightly higher temperature than your average oil and gas basin. And as a result, we were dealing with some drilling challenges that we thought were related to these high temperatures. So it caused me to do some research into high temperature drilling to look for solutions. And every paper that I found on how to overcome high temperature drilling came from this field called geothermal. And I had never heard of geothermal at that point in my life. It was not a huge industry then. It's not really on everybody's roadmap, but I became fascinated by it. And around this same time, you were starting to see things like the major 1 in 100 year floods that have now happened with quite a bit of frequency in Houston. So I had always been quite interested in climate change. And I think some of the, personal impact of seeing things like, once in 100 year flood happen consistently in Houston around that time period really sort of motivated me to get more interested in climate change. And so as I started thinking about moving my career in a direction that's focused on clean energy and climate solutions, I just became ecstatic when I learned that there was an entire realm in the world of renewable energy that relied completely on drilling technology to be successful. And as a drilling engineer, I found that quite appealing. So it was about 10 years ago that I really became quite obsessed with geothermal and really saw it as a really interesting way for me to move my career as a drilling engineer, into the clean energy sector.
Yeah, exciting. And I think there's a ton of potential. I assume you agree, but certainly tell me if you don't, for folks that are in the oil and gas industry. And it's not even necessarily, I think sometimes people forget what the word transition, when we talk about energy transition, means. It doesn't mean like, tomorrow everything changes, but there's even opportunities for folks in the oil and gas industry to still be in the oil and gas industry, but work on geothermal on some sites and get some additional skill sets and kind of go back and forth. No?
Absolutely. And I think, maybe to fast forward the story a little bit, I'll talk about in particular some of our oil and gas industry partners that have been a huge part of this journey. That realization, the more I looked into geothermal, the more I also realized that there had been this big technology gap between all of the innovation that occurred that made oil and gas drilling so efficient that it took off this massive shale revolution that really caught everybody by surprise and made the United States the leading producer of oil in the world, and it was a true technology innovation story. Well, I started looking at the geothermal sector. And the geothermal sector is sort of, it's much smaller. Obviously, it's overlooked. Doesn't get the same attention as oil and gas does often. And what I found was that even though there'd been this tech revolution in how we drill wells in the oil and gas world, that really none of that technology had been applied to geothermal. Most of the geothermal drilling projects were using very outdated drilling rigs. There was no software, there was no automation, there was very little directional drilling. So I saw a big opportunity to bring, these what were really brand new technologies in the early 2010s to the geothermal sector. So I quit my job in 2015. I went to Stanford. I pursued my MBA there. I also got my master's degree in the School of Earth Sciences. And I really spent my whole time there pursuing this idea of, how would you take technology that had been developed and innovated quite recently in the oil and gas space and apply it to geothermal, an adjacent sector, but it has some differences. And quite fortunately for me, I got to work quite a bit with the Stanford Geothermal Research Group, where they've got a wonderful geothermal division at Stanford. And my co-founder and our CTO had just finished his PhD there, working on novel reservoir and production methods for geothermal. And we hatched the idea to do a few things that we've now. Dr. Jack Norbeck is his name. He's our co-founder and CTO of Fervo. We launched this idea in 2017 and formed Fervo, and we really formed it around this idea that drilling had gotten a lot more efficient and cheaper, and so we could bring horizontal drilling to the geothermal space. The second is that the same way that there's flow rate challenges in the oil and gas world that were solved with multi-stage well stimulation for shale, we could bring that to the geothermal world as well, so that we could very consistently create highly productive, high flow rate wells, incorporating horizontal drilling and multi-stage well completion. And then also bring in modern data sets like distributed fiber optic sensing, which is a technology that we do quite a bit of work on to actually measure, understand, and optimize these projects faster. So that's what we did when we formed the company in 2017, and we've been at it for about 5 years. And I just wanted to provide a little bit of that background to talk about a couple things, especially when we talk about the oil and gas transition. We were fortunate. We founded the company when we were at Stanford. And then we got a great research grant from a program called Activate that allowed us to spend the next 2 years working at the Lawrence Berkeley National Lab, embedded inside their energy geosciences division, to keep iterating on these projects. But whenever we wrapped up our 2-year program there, we actually opened a Houston office. I relocated back to Texas, and our headquarters now and our biggest office is in Houston. And the reason for that is whenever you think about sophisticated drilling and geologic technology and particularly the engineering skill set to do it, there's no better place in the world to locate that talent and to find those partners than in Houston. And so the majority of our team is actually folks we've hired from the oil and gas industry. We also, on the commercial side, and I'm happy to talk about this, have hired a lot of folks from wind and solar companies that have experience in development there at a much larger scale than what geothermal's done before. So we talk about our team always in terms of how do we bring the best technologists from the shale revolution together with the best developers from the renewable industry all on one team to solve these challenges. And so that's what we do. We have an office in the San Francisco Bay Area. We've got an office in Houston, and we really work together across that. But, it is really important for me personally to see this as an energy transition solution. I started my career in oil and gas. I have tremendous respect for the people that I worked with in the oil and gas industry. And for me, this is a really big part of it. I found once people realize that their skills can apply in a new type of energy generation in the clean energy transition, they get a lot more excited about it. So everything from hiring folks to who we partner with, we're really fortunate at Fervo to count among our investors, for example, Helmerich and Payne, which is the largest drilling contractor in North America, has and leading technologist in the oil and gas sector, is an investor in Fervo. Liberty Energy, who's the largest well completion and pressure pumping provider in North America, is an investor in Fervo. And so really it is truly about finding cross collaboration with the oil and gas sector, and particularly the oil field service companies, to bring these technology solutions to geothermal systematically.
It's really impressive and fascinating. I've heard you speak before about one of the innovations that Fervo has brought is this. So basically taking what you were just talking about a little bit there, and let's go a little bit further into it, the horizontal drilling, that one of the biggest risks in geothermal, similarly in oil and gas, is spending the money to drill and then coming up dry in the case of oil and gas, or I guess cold in the case of geothermal, not getting to heat. So what y'all have done, if I understand this right, is basically you're going down vertically, but then going horizontal, so that risk of not finding heat is much less. So you're taking this innovation from oil and gas and actually applying it to an emission-free power source.
Yes, that's exactly right. Now, so I mentioned before that geothermal, has been around for over 100 years. That's when the first plant was built in Italy for geothermal. And I also had mentioned that we're really the forgotten renewable. There's not a lot of attention historically that's been paid to geothermal. And so you may wonder why is there a resource that's been around for 100 years? It's virtually limitless. It's 24/7. It's carbon free. It kind of checks all the boxes. Why is that not taken off? And really, it's come down to a question of cost, and it's come down to a question of technology not being able to keep up with the resource as we've had to drill deeper and deeper to find the right geothermal. So, that project in Italy that was developed 100 years ago, they were able to develop it because the steam was literally coming out of the ground at the surface. There's not that many places in the world that look like that. And you look at the big projects for geothermal, where the industry really took off was in the 60s and 70s. And those were in a lot of power plants developed in Northern California and in New Zealand and then Iceland, places that have really naturally occurring ultra high temperature geology very close to the surface. Now, what's happened in the sector is as those resources were drilled out, and, we ran out of these really limited number of ultra high temperature, very shallow resources. The industry had to drill deeper and deeper and try to find more systems that weren't as easy to spot. And that's a really tough technical challenge. And so all of a sudden, if you have to drill 10,000 feet deep instead of 3,000 feet deep, that's difficult. And if you have to drill into an area where you're just guessing geologically that there may be a good heat resource instead of being able to see steam literally coming out of a surface vent, that's a lot more difficult to hit. And so as we moved away from these world-class resources like the geysers and projects in New Zealand and Iceland to deeper and deeper resources, the technology didn't keep up with that challenge. And so it became that cost prohibitive. And really the main issue, and one of the big challenges when you look at geothermal compared to wind and solar, you can actually download, for example, from NREL, a pretty good insolation map that tells you exactly how much sun, within some range of uncertainty is going to hit a spot anywhere in North America. So it's quite easy to predict what your output's going to be. The geothermal resource is 2 miles beneath the surface of the earth. We have some guesswork about where it is, but ultimately you've got to drill it in order to figure out where that is. So there's just a little bit more risk in what you have up front. And then historically, the way geothermals worked is you've drilled purely vertical wells. And left them with very simple well completions. So you drill these wells down, and I think a lot of people don't quite. So just to talk about how geothermal works, You drill sets of injection wells and production wells. You pump the cold water down the injection wells. It has to flow through the geothermal reservoir to your production wells, and then it returns to the surface at high enough temperature that you can capture energy from it at the surface to create that electricity. Now, historically, you've been challenged because actually those wells are really only, they're less than a foot in diameter. And so for about 1 out of 3 projects that people have tried to drill for geothermal, they drill down and you've got this well thousands of feet deep, only a foot in diameter, and actually doesn't hit anything that is commercially viable from a geothermal resource perspective. And so the challenge has always been drilling's expensive. It could cost you $5 million plus to drill that well. And 1 out of 3 times you come up with nothing, you really can't really scale that as a resource in the very competitive power markets. And so if you want to scale geothermal, the problem that you have to address is how repeatable it is. You can't afford to drill a bunch of wells that don't actually produce anything. So the innovation that Fervo has worked on is, rather than drilling vertical wells, we drill deep and then we drill horizontal wells. So our production and injection wells aren't next to each other vertically. They're actually stacked on top of each other horizontally. So we'll drill 10,000 feet down, we'll drill 5,000 feet horizontally, and we'll place these wells a few hundred feet apart from each other. And that way you're actually not just trying to find that resource with, maybe a 7-inch pipe in the subsurface, but I've got over a mile at which I can access that subsurface. And it turns out that whenever you do that, you're able to overcome a lot of these, hit or miss qualities of geothermal and create a resource that consistently delivers, across a very wide set of geologies. So what we're doing is actually opening up. There's really one main thing that we're doing, and that's increasing the hit rate and consistency of geothermal drilling. And that has a consequence of allowing us to get on a learning curve, to plan out large scale projects in a way that the geothermal industry hasn't before, and really bring on much larger scale resources in geologies that wouldn't have been economically viable previously. And that's the main innovation. And really the beauty of what we're doing too is we can move extremely quickly to market because I don't have to invent, and Fervo as a company doesn't have to invent every single technology solution from scratch to make this work. It's really about how do we tap into the skill set and already existing tools and equipment of a very sophisticated and technologically advanced oilfield service industry and get them to work in a new way for our projects. And so that's really what we're doing at the end of the day.
So I want to talk a little bit more about the resource, and we will put in the show notes a link to a fantastic podcast that Dave Roberts at Volts did with Wilson Ricks of Princeton Zero Lab. I would encourage people to listen to that. They went deep on this. We're not going to go super deep on this, but I think it's a really important point, especially this is the Texas Power Podcast. There's a lot of discussion in Texas right now around dispatchable resources. I think actually sometimes too much, not that dispatchability is not important, but I think sometimes we're also not talking about flexibility and having those flexible resources. So on this podcast, we've talked with previous guests. Pat Wood is an example about energy storage. We've talked about demand flexibility and that resource. Geothermal has these properties and this potential of actually being a renewable resource that can actually be both dispatchable and flexible. I don't understand it super well, but I'm hoping you can help me and our audience understand it a little better. But the idea is basically, right, is you're getting steam from deep down underground. You're heating up water to create electricity. You can manage that flow rate to produce power at variable rates on demand. So when maybe wind and solar are lower, you can sort of let some of that pressure and steam out and produce more power. And when you've got a ton of wind producing, you can kind of keep that underground a little bit more and hold it till you need it. Did I say that well?
Yeah.
Correct me where I got it wrong and maybe explain it better than I did.
Okay. You got it. And if you'll indulge me, I may back up a little bit and explain
Please.
Sort of the market motivation and what's happening on the power sector that actually makes this more important. Obviously, like a lot of people in Texas, I lost power during the Texas freeze as well. And so I think that's one of these things that's vaulted reliability back into the energy conversation. Whenever you talk about energy, you're always talking about, what can be clean, affordable, and reliable. And it's really depending on whatever current events are happening those, there's a different order depending on what's the priority there. And there's a couple things that happened, the Texas storm being one of them, but then also the rolling blackouts that occurred in California in 2020. That's really put reliability back, to maybe being the first in that order of clean, affordable, reliable. And so that's one of the things that's happening. It's also a story too about our ramped up ambitions on decarbonization. If you go back 10 or 15 years ago, or 20 years ago, I guess, people were just starting to roll out renewable portfolio standards. There were big questions about whether or not wind and solar and renewable resources could ever achieve 10% on the grid, much less more ambitious targets. And so that was sort of where we started. And you don't really have to worry about a lot of these issues on variability or intermittency and other things whenever you're just talking about a resource being 10% of the grid. But what happened, obviously, is wind and solar were quite successful. They got far cheaper, far faster than anybody envisioned. And so all of a sudden, the 10% renewable portfolio standard targets didn't look unachievable. They looked kind of mundane. And now we've seen many states, Texas being one of them, and California being another, really blow past that. And that's really emboldened people to take the next step on decarbonization. And so a big trend we've seen in the market is, rather than renewable portfolio standards be 10% or 20%, in the last few years, we've seen people look at the success of wind and solar, look at how quickly we're decarbonizing the grid, and ramp up those ambitions to be 100% renewable energy or 100% clean energy. And that requires a very different set of tools than getting to 10%, right? And so if you want to talk about matching every single hour of the year with clean electricity, it's a very different problem than, can we get 20% of our grid to be from renewables? And so, Hawaii was the first state to pass this 100% clean electricity standard, but then California did the same with SB 100. And now I think there's, I lose count, 11 or 12 states that similarly have 100% renewable energy standards. And that's really forced people to look at the question again of not how do we get a little bit of our grid from renewable energy, but what kind of system as a whole can produce carbon-free electricity 24/7. And that has brought geothermal back into the conversation in a big way, because we do have this attribute that is not true of wind and solar, that we can work 24/7, we can work on demand. And so that's sort of our picture. And when you look at the studies on deep decarbonization, even with low cost batteries, every study kind of comes up with the same result, that getting more than perhaps 60 to 80% of your grid from clean electricity requires you to get solutions that go beyond wind and solar and batteries if you want it to be cost effective. So as we think about geothermal, what our company's mission is can we make geothermal scalable enough and affordable enough that we can be that missing piece, that 20% that allows a fully decarbonized grid? And that requires different ways of working, So geothermal, much like wind and solar, shares some of the same attributes that they do, which is that, we have no marginal cost. It doesn't cost me any more money to run geothermal for the next hour. I'm not burning any fuel. It's a fuel-free resource. All the capital's kind of upfront and building out the system, very similar to a wind and solar resource. And so historically, there's never been any reason to ramp geothermal up and down because it doesn't cost any money to run it from a marginal cost standpoint. But it's never been a technical limitation for geothermal. Geothermal's always been able to ramp up and down as needed. And whenever you look at places like the Puna plant in Hawaii or the country of Kenya, where 60% of the electricity comes from geothermal, those geothermal plants ramp up and down all the time because there's such a big part of the electric grid there that they have to. So it's always been a feature of geothermal that it can ramp up and down and provide these extra grid services. The podcast you're referring to is actually Wilson Ricks at Princeton University is one of our research partners actually for an RPE grant we got earlier this year that we're quite excited about, a technology we call Fervo Flex, is a little bit different. So historically, whenever people want to ramp down a geothermal power plant, what they've done is they've actually kept producing the wells, but then just bypassed the power station and allowed the power output to go down. As a result, whenever they want to bring it back on, they pipe the fluid flow back into the power station. And so that's how they've ramped up and down. We wanted to look at this problem a little bit differently. We're looking at the grid now and we're understanding, for example, in the western parts of the grid that we work on, quite regularly, daytime power prices are negative because there's so much solar on the grid. And so actually there is a reason to curtail and there is a reason to shift it around. And what we're scoping out and working on with Princeton is, rather than doing the traditional way of geothermal ramping up and down, where you divert flow around the plant but keep producing the wells, could you actually shut the wells in or curtail flow for them during these really low cost times? For example, during the daytime, whenever there's a lot of solar production, and use that throughout the day to build temperature and pressure in your geothermal reservoir, so that when the sun sets, you can open those wells back up and actually get a period of boosted flow and shift that energy consumption and production from the daytime to the nighttime on solar heavy grids. And we're quite excited about this. And I can tell you a lot of our customers and RPE and the Department of Energy is quite excited about this as well. And it's just one of the examples of a unique attribute that geothermal can provide to a rapidly changing grid that's quite important. So, yeah.
What is the just rough order of magnitude of like what's the difference? Like if you're doing what you just described and reducing output in the say 12, 1, 2 p.m., but then you really need it at 8 or 9 once the sun is down, is it like a 2x flow? Is it 3x? Or do we not know? 10% more, 20% more? Or do we not know?
It's an interesting question, and this is actually kind of the scope of our research project with RPE. Is the project is not relying on anything that the project is not relying on anything that's hasn't been proven out or technically done or shown in the field. You can obviously build pressure in reservoirs. You can get periods of higher flow. The question is, how do you take those parameters and create a system that's optimized? And the answer is going to be different depending on where you are. On a solar heavy grid, it may make sense to take production to zero during the day, or even become a net energy consumer during the day, and then really have boosted output during the evening hours. And so I think that's something, you might have a different system than, for example, if you're on a grid that might have a wind heavy system, where what you're really trying to do is bank energy for a multi-day period of no wind sometime in the future. So it's all a systems design question. I think the thing that's quite exciting about this system relative to, some of the other things in the long duration energy storage space is that, again, this is something that's based off of well understood and longstanding principles of how subsurface reservoirs work. And so, really all of those things can be done. If you read some of the publications we've done with Princeton on this, we've looked at everything from, a 4-hour storage solution to a 100-hour storage solution and everything in between. So there's a lot of things to optimize within that.
I have so many more questions, but we're going to keep moving. This is so interesting, and I think so relevant to so many conversations going on all over the place, but particularly in Texas, where you were talking about the renewable portfolio standard, and I forget the year that the 10,000 megawatt goal, it was either 20. It was fast in 2005, and I think it was like a 2020. It might have been a 2025, whatever it was. It was a 10,000 megawatt goal. I think we're sitting here today with about 49,000 megawatts, so 5x the amount, roughly in the same time period. So it's just an incredible success for the state to have all of this. Wind and solar, the tax base, the jobs, the low cost power associated with that. And I really do think geothermal, it'll take a while, but it's coming next. This is the Texas Power Podcast. So let's talk about the resource potential within Texas. So you were talking earlier about your early experience working in the Eagle Ford, looking at the geothermal maps of Texas. It looks like that's a great area of resource, and possibly East Texas as well. You mentioned 10,000 feet. The temperatures there are good, but I guess two questions here. Do you have to go even deeper than that to get to the best resources, or can you really hit a nice resource at 10,000 feet? Like, how deep do you have to go to get to the really great resource? And can you just talk about Texas and what the resource looks like here, maybe relative to other places?
Sure. It's a great question. And actually, I'm going to reference back to that framing I talked about earlier, where, the earliest days of geothermal, you could do these projects because you just had these really high quality, ultra shallow, ultra high temperature resources. And then there's a cost curve. And the whole question is always, can you drill deep enough in a cost effective manner to reach the temperature you need? And for an effective geothermal resource, you really need temperatures that are at least 300 degrees Fahrenheit, and you get much higher efficiencies the higher you go from there. So that's really what you're looking for, is how deep do you have to drill to get to 300, and then the amount of power you can output from 400 degree resources is significantly higher than you can get from 300. So it's not like 300 and you're good to go. It's you want to be able to get higher temperatures than that. And so the approach we've taken is we believe this is going to follow a learning curve. We believe that as we scale and start drilling thousands of wells, this is going to get cheaper and cheaper. And so the problem statement we gave ourselves is, where can we actually go and drill these resources in the most cost-effective manner today to capture those learnings so that we can iterate and design projects that are lower cost in the future. And for us, that's actually turned out to be in traditional basin and range geologies in the Western U.S. And so our first project, part of Google in the last few years has launched a very ambitious 24/7 carbon-free energy initiative, where rather than averaging out their energy production over the year, they actually want to power every single hour of their data center operations locally with clean electricity. And that's a very different problem statement than annually averaging it out. And so as part of that initiative, Google's looking deeply at geothermal. And we actually announced the deal last year to do a demonstration project in northern Nevada, where we're drilling a set of wells to power a Google data center there. So that's where our first large scale project is. That project is going quite well. We're advancing quickly there. Just this year, we've drilled the first two ever horizontal geothermal wells ever drilled in the geothermal industry. And we're going to be putting that project online early next year. Quite excited about the technical results and our long-term partnership with Google there. And the reason we've chosen to go there. Yep.
Just real quick, how deep do you go for those resources in California?
Those are
8,000. Not 10,000 feet. 8,000.
Those are 8,000 feet deep. Mm-hmm. Yeah, and 8,000 feet deep, and we're getting really close to that, sort of 400 degree temperature range that you want to get. And so, in our portfolio, the other area we've announced is a project in central Utah that we're partnering with several power buyers in Southern California, and we're going to start drilling that project next year. Again, a project where we can keep these relatively high temperatures at perhaps 8,000 feet. So relatively shallower than a lot of actually oil and gas wells, but still meeting the high temperature requirements we can. Now, our mission for this is that we've got the potential to bring on gigawatts of electricity of that kind of shallower, high temperature resource in that basin and range area. And developing those gigawatts of electricity is going to require us to drill hundreds of wells in that area. And if you have followed the history of the shale revolution, it was quite incredible just in the span of my short career with BHP Billiton, how much better and faster we got in a very short period of time. And so what happens is that the more you drill, the more you learn, the more you iterate, the more you come up with engineering solutions and design optimizations that allow you to go faster. And so you see costs start dropping precipitously as you really get to scale applying new drilling technology to resources. And so if you look at what's going to happen as we scale there, all of a sudden you can start talking about drilling much deeper resources and still being cost effective. So ultimately, every country in the world, every state in the United States is going to have something that meets our criteria in terms of cost and depth if we can get the cost to compress enough. And so this sort of brings us to Texas. Texas has what I would call good but not great geothermal resources. It's not going to be competitive with the most high temperature stuff in Iceland and California and New Zealand and Kenya, but it's also much hotter geologically than other places. The whole reason I started this is because drilling high temperature wells in the Eagle Ford, but the temperatures to get to the temperatures that we would like to see to have effective power production, it's not quite 8,000 or 10,000 feet. It's more like probably 13,000 to 15,000 feet. And that may not sound like a huge difference, but drilling costs go up exponentially as you try to get deeper. And so we think we can compress costs enough that we can access resources in Texas and really in places around the United States, over the medium to long term. And that's really what would get this to be a multi-hundred gigawatt resource in the United States. And that's really the prize we're after. That's not to say that there's not creative ways and solutions to do it. One thing, another Houston-based company that I encourage people to look at that we're big fans of is a company called Criterion Energy Partners. And they're actually looking at developing geothermal resources on the Gulf Coast today. And one of the things that's innovative about what they're doing is, bringing smart drilling technology to the table, but also looking at where are there big industrial consumers that can use both the electricity generation and the heat that they provide, on site in one facility. And you can help your economics there quite a bit by by doing that. So there's going to be ways and pockets in Texas, I think even today, where we're going to see economic geothermal electricity. I also think if you look at the technology cost curve that we're going to be on by the next decade, we're going to be talking about being able to bring on enormous amounts of electricity from geothermal in Texas around the rest of the U.S. So there's different ways to do it. I'm bullish, even though we're doing our first projects in the Western U.S., in Utah and Nevada, and chasing after the best geology there. I'm quite bullish over the long term that we're going to see projects done here in Texas as well.
That forgive my ignorance, the 13 to 15,000 range you're talking about, the oil and gas drilling typically is not going that deep, right? It's much shallower than that. Yeah.
Typically, no, but I think I'd say the thing about the oil and gas industry is it's a massive industry. There's been hundreds and hundreds of thousands of wells drilled, and so you can find all kinds of projects everywhere that have been drilled deeper than that. That's deeper than certainly the true vertical depth of a South Texas or West Texas Permian or Eagle Ford well, but it's definitely not unheard of in terms of the technology limitations. It's not. There's no fundamental technology limit that says you can't drill to 15,000 feet. It's just a question of if costs go up exponentially with depth, at what point are you bringing those costs under control enough that you can create electricity from a geothermal power plant in a cost-effective manner.
So let's talk about that cost effectiveness and some of the market drivers here. So first of all, am I right that there was a change from the Inflation Reduction Act with the geothermal investment tax credit and production tax credit?
There was. So one of the big challenges for geothermal historically, when I say forgotten renewable, I mean that term in every sense. And geothermal is often forgotten, for example, in the investment tax credit and production tax credits that other renewable energy resources received. So I oftentimes get questioned, why hasn't geothermal taken off? And in a lot of ways, it's been a discrete policy choice to not have geothermal take off. So on the tax credit side, we don't get the same tax credits as the geothermal industry, as the other renewable industries get. But then even on the permitting side, the Energy Act of 2005 put in a large number of categorical exclusions for oil and gas drilling on federal lands that allow much more streamlined development of oil and gas drilling. But that policy did not extend to geothermal. So geothermal has to go through a much longer and much more intensive permitting process than oil and gas wells do, even if it's quite similar well construction. So being forgotten hurts geothermal in many policy ways. So we have to develop projects oftentimes that don't have the economic support that other renewables get, but then also don't have the permit streamlined support that fossil fuel projects get. So we kind of get the worst of both worlds. We've embarked on a number of advocacy efforts to raise awareness of these issues. They've been somewhat successful. I think in the Inflation Reduction Act, one of the big things that is exciting for us is, for the most part, not completely, but for the most part, we've finally been put on a level playing field with wind and solar from a tax credit standpoint. And it's set up in a structured way that it's actually going to maintain being on a level playing field for at least the next 10 years, which actually gives us some certainty around planning. When geothermal was included in prior tax credits, it was hit or miss and never longer than 12 months. And so really difficult to plan a business around that. And the IRA brings a enormous amount of certainty into the business for us.
And that change begins in 2025, or is it earlier than that?
It begins next year, starting next year.
Next year. Okay, great.
Yeah.
So I think in 2025 it switches to like a technology neutral, right? So that a lot of the gripes you hear from certain folks about the incentives and subsidies for wind and solar is that it's picking winners and that kind of stuff. At this point, it's going to be, if you don't pollute, starting in 2025, if you have gas with carbon capture, geothermal, so on and so forth, you would be eligible for either the ITC or PTC, and you get to choose. That's right.
That's right. And that transition to the tech neutral tax credit, and then when that sunsets is what gives me the confidence to plan my business for the next 10 years, because we know there's going to be this discrete tax credit that geothermal is finally included in for the next couple of years, and we know that we're going to be included in the tech neutral tax credit as it transitions to that a few years out as well.
Yeah, and I believe it's 10 years or 75% carbon free or something like that, but whichever is the longer one. So hopefully we reach 75% carbon free much sooner, but it'll last 10 years. But if we don't reach that goal, it would actually extend. So that is a big change in the IRA. Let's talk a little bit more about some of the market dynamics here. So some of your earliest customers, announced projects. You've got two projects in California, one 20 megawatt, one 40 megawatt. Congratulations on that. It's a big deal to get over that hump and get those PPAs signed. You mentioned the partnership with Google on 24/7. So a question here about Texas. I'm wondering, well, maybe this is more a statement and you can comment or answer it or not. But in my view, it does look like, in a lot of the ways that Austin Energy and other munis, co-ops were market makers on, well, really Austin Energy in terms of wind. In the early days, I was, as a resident of Austin 20 years ago, signed up on a wind choice, which I paid extra for at the time. But within a couple years, as gas prices went up, I was paying less than everybody else. They conceivably could do something like that on geothermal and be a market maker there. So I'm interested, like where, if you think that's a high potential area or other potential customers in Texas, maybe local governments or if there's others that are sort of obvious candidates. And then would love to hear a little bit more about that partnership with Google. You mentioned just a few minutes ago the 24/7 project they're doing, which I think is really intriguing. And I think that they are a market maker there. I think a lot of companies are going to go there. And just to help our listeners understand, Google, I think like 5 years ago said they were way ahead of their pace. They had already purchased 100% clean energy to offset all their usage, but it wasn't matched up to the time that they were actually using that power. And so this is one of the reasons they're really interested in geothermal. It is one of the main critiques of wind and solar is they don't necessarily match the demand. You can use demand flexibility. You can use storage. You can also use geothermal to match that. So I'm interested, are you seeing others, doing things similar to Google and trying to get into that? Is this a one-off? Is Google really unique here, or do you think that is actually going to lead to some broader market changes from other corporate purchasers?
Yes is the answer. And just to talk a little bit about scaling new technology in the power sector, it is difficult to get anything new in the power sector, and it's because you face this major chicken and egg problem. Power buyers are notoriously risk averse, and I think oftentimes wouldn't do anything differently if they weren't required to. They get to where they understand and trust ways of operating the grid and understand and trust different resources, and don't really want to change because, and to their credit, it's their job to keep the lights on. And why would you want to add any risk to that equation or uncertainty or complexity? And so the downside of that risk aversion, though, is it just makes it pretty much impossible for us to ever do anything new in the power sector. And when we had conversations with customers when we were starting, over and over again, what you hear is, once you have a few plants that are up and running and we can examine the data, we'd be really excited to do a deal with you. And it's like, okay, well, how do you get a few plants up and running if no one's willing to buy it? And so oftentimes over and over again, you see there has to be some sort of external forcing mechanism to drive this. And that could be a private sector or regulatory solution. So on the private sector side, Google did, it was in 2018, traditionally what you had is this 100% renewable energy goal. And there's over 100 corporations that have signed up for this goal. And it's basically been defined as, can you buy enough wind and solar that at the end of the year, when you add up how much solar or wind you bought, doesn't matter where in the world it is or what time it was produced. And then you look at how much you consumed at the end of the year. If those two columns are equal, you say, great, I'm 100% renewable and move on. Well, of course, anybody looking at that can realize that that's, 100% renewable doesn't really mean you're powering your operations with carbon-free electricity. And so, if the sun's not shining, those operations are being powered with fossil fuel energy, just like everything else on the grid is. And so, if you want to move to that next catalyst, you have to come up with a new standard. And there's now, Google's led this effort with the 24/7 carbon-free initiative, but there's a UN compact on this. There's many other private sector companies that have signed up. And most of them have said, all right, we've hit our 100% renewable energy goal, or we have line of sight to hitting that pretty quickly, but what's next? We still, we want to move beyond accounting and into the real world in terms of actually powering our operations with clean electricity. And that has provided a catalyst, this more ramped up ambition. And it's why we did the deal with Google. And as a private sector innovative technology company, we need some sort of catalytic big customer to come through and say, yeah, we understand the value of this long term. We're going to partner with this company to work through all the issues of it to get this onto the grid. So Google's played that role for us, and it's been tremendous. That's an example of sort of a private sector led initiative that helps catalyze new technology and solves that chicken or egg problem. The other thing that's been interesting for us is a regulatory change. I mentioned before how important reliability is in grid planning now, and it's always been important to grid planners, but is it the biggest priority is always the question. And the rolling blackouts that occurred in California in 2020 were a huge wake-up call for grid operations. And what you'd see in the grid operations there for years is all the different power buyers, the load-serving entities in California. Everyone recognized the need for more clean, firm power on the grid, but everybody just said, well, yeah, somebody else will buy it, right? And so there wasn't anybody stepping up and playing that role. And so the California Public Utility Commission said that those rolling blackouts in 2020 were enough of a wake-up call that we weren't going to let everybody sit around and say, oh, huge problem here, somebody else will solve it. And so they actually required all the different power buyers to have some skin in the game. So there was a ruling that came out last year in California called the California Public Utility Commission midterm reliability ruling that required a specific amount of reliable capacity to come onto the grid. And there was a carve out within that for long lead time resources that were for specifically clean, firm resources that could operate 24/7. And of course, geothermal is by far the best solution to that. So we quickly went from an environment where everybody said, well, obviously we're big fans of geothermal, but go sell it to somebody else, to everyone having to be required to buy some geothermal in the state. And that's created this huge catalyst for the sector. And that procurement order was 1,000 megawatts. And 1,000 megawatts is really important because that's enough to allow our industry to scale, come down that learning curve, prove out these new technologies in the field. And we're in this big renaissance right now for geothermal, in part because California has stepped up and solved this chicken and egg problem in a really important way. And so that's been really big for the industry. And it's a model we can see, being done in other states around the country too. One of the challenges we have with geothermal is the lack of public awareness on it, right? So like you see these solar choice programs or wind choice programs, and you see people opting into that. A lot of people don't know about geothermal. So like, are you going to get consumers to understand the value of it? That's a public awareness thing. So, I think there could be a huge role for somebody like Austin Energy to play in the future to catalyze geothermal. But we need to make sure we're raising awareness about geothermal so that people actually understand, this is every bit as important as wind and solar. And in fact, even more so, because this is going to be that critical piece that allows us to keep the lights on 24/7.
Yeah, quick plug for the Texas Geothermal Energy Alliance and a previous podcast I did with Barry Smitherman, the chairman and president of that organization. They're working to raise that awareness as well. So just, I think just two more questions and then we'll go ahead and end. One, so we're at this will be released later, but at the time we're talking, it's quite cold in Texas. It's going to get a lot colder. You've talked about geothermal being 24/7 resource. Is there any sort of like drop off in production in extreme cold, extreme heat, or other kinds of extreme weather? Are there D rates associated with it? Like talk to me about how it performs in extremes.
Yeah. So it does great in extreme cold weather. I mean, Iceland is notorious for being the big geothermal country. And in fact, it's a great complement for cold weather. Geothermal efficiency actually goes up with the colder the temperature is, and it goes down in the hotter times, which historically has been a big challenge for the grid. But now solar's gotten so cheap that there's recognition that those really hot summer days are going to be met with solar pretty much every grid in the world. And so really the big planning issue, you look at this, I mean, Texas is a prime example. Texas is known typically for our hot summers, but even in Texas, the most acute grid planning need is moving to the wintertime. And so what we're seeing is there's a huge effort. It's very important for there to be a resource that works in cold weather temperatures. And so the fact that geothermal works so great and actually increases output and improves efficiency in the wintertime is becoming a big boost and plus for the resource. And so that's something that, we're looking at geothermal, one is a great reliability resource, but then also a great paired hybrid solution with solar, because solar works best during the day and geothermal works best at night and in the wintertime. So there's a lot of great compatibility there that will make a big difference for the future.
Yeah, there's a lot of focus on wintertime, obviously in Texas right now, and a lot being done around, firm fuel and stuff like that. But it's really important those get written technology neutral, or even with some kind of, help potentially for geothermal, because it could be a really big, important resource going forward, all times of year, but particularly in winter, which, as you mentioned, is a big problem. Last question I want to ask you, and I'll ask you to. Your obvious answer is going to be geothermal and enhanced geothermal systems. So we'll take that as a given. But I kind of want you to you're a smart guy. You've been around energy for a long time. You've studied a lot. I'm interested what you think might be one besides EGS. When we look back in 10 years, what's one thing, a technology, a product, a service, a policy, whatever it might be, that'll be widespread and in common use that will surprise people? This is a question I like to ask guests at the end.
Oh, I don't know how surprised you'll be about this, because I think you nerd out about energy issues as much as anybody. But it's not a new technology, but I'll tell you, the make or break technology for the energy transition is transmission. It doesn't matter if you're talking about nuclear or geothermal or wind or solar or battery solutions. It absolutely doesn't matter if we can't figure out how to build the right transmission lines to have a strong grid to move that power from point A to point B and diversify across these resources and make it happen. We're not going to do anything in the clean energy mix. I hope we build transmission. I hope it's not a big surprise. I don't know. I don't know if it's the farthest thing you can get from a whiz bang technology answer. But this is my current. I'll use any platform I have to tell people about the urgent issue of figuring out how to build a strong grid and a great electricity transmission system. So that's my answer. If we do it in 10 years, our lives are going to be a lot easier in terms of providing a clean, affordable, reliable electric grid. If we can't figure it out, man, are we going to have a hard time moving forward with providing the kind of electricity that society needs.
It's a great answer. Hugely important aspect of the energy transition. Tim Latimer, thank you so much for being on the Texas Power Podcast. Appreciate you.
Great. Thank you.